By using integration by parts, find the integral of x e to the 6x dx. The diagram shows part of the curve with the equation y equals root x e to the 3x. The shaded region R is bounded by the curve, the line x equals 1, and the x-axis from 0, x equals 0 to x equals 1. Find the volume of the solid generated when the region R is rotated through 360 degrees about the x-axis, giving your answer in the form pi p e to the 6 plus q, where p and q are rational numbers. So let's have a look at this question then. Here it is here in summary form. So the first thing to do is do the integration by parts. So let's do that then. The answer is equal to, I've already labelled this du and this v du. So it's u, v, so u is e to the 6x, and we divide by 6, don't we? E to the something, if we differentiate this just to check, e to the something differentiates to e to the something, multiplied by the something differentiated, which is 6, and then that will cancel. So we drop a 6 underneath then. So that was u, v, so I'll put the x there, minus the integral of u, which is the e to the 6x over 6, times dv, which is 1, isn't it? So that's equal to x e to the 6x over 6 minus e to the 6x integrated then, e to the 6x, and the 6, another 6 comes underneath to be with the 6 already there, plus a constant of integration. So that's what we've got then. So that's that integration done. So here this curve is root x e to the 3x, isn't it? Find the volume when it's rotated about OX, this volume here. So you've got basically cylindrical segments here, cylindrical discs, thickness delta x, height y. So here, part B then. So the volume is equal to the sum of all these discs, and they're of volume pi r squared. R is y, pi y squared, times thickness delta x, so pi y squared dx. Sum these discs from 0 to 1. So that's equal to then pi. Now y squared, well, if we look back up, y squared, square this and square this, you get x. And square this, you'll get times you add, don't you? So you'll get 6x when you add the 3x and the 3x together. So you actually end up with x e to the 6x dx. So now we can just say the volume between 0 and 1, pi. And it's this integral here, isn't it? X e to the 6x over 6 minus e to the 6x over 36. And evaluate that between 0 and 1. So that's equal to top value, take bottom value, put the 1 in then, 1 e to the 6 over 6, put the 1 in here, e to the 6 with a minus over 36. Take away the bottom value, put 0 in here, we get 0, minus, put 0 in here, e to the 0 is 1, so it's 1 over 36. So we end up with then pi, which is what we want. 6 over 36 minus 1 over 36 is 5 e to the 6 over 36 minus is a plus 1 over 36. That's what we wanted to show, wasn't it? P and Q, which are mentioned here in this form, which we've done.